Hello and welcome to another video. In this video we're going to be continuing on with TypeScript 175 and we're going to be doing Pacific Atlantic water flow. So in this problem you have a matrix, an island that borders the Pacific and Atlantic Ocean as shown in this picture, and the Pacific Ocean touches the island's left and top edges, so these ones here, and the Atlantic Ocean touches the island's right and bottom edges, so these ones here. Island is partitioned into a grid of square cells. You're given an n-by-n matrix. Heights, where heights are c, represents the height above sea level of the coordinate. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. Water can flow from any cell adjacent to an ocean into the ocean. Return a 2D list of coordinates. Result where rho RC, or result I RC, denotes that rainwater can flow from cell RC to both oceans. So essentially, these highlighted cells are the ones that you can flow to both oceans from, because let's just take a look at some of these. So anything that touches the Pacific and the Atlantic Ocean automatically qualifies, right? So this and this automatically qualify. Now for something like this can flow to the Pacific because you can flow down or to the same number. So you can flow like this is one valid path, and then to the Atlantic you can go like here. Similarly, this one can go like this or like this. You know, you can flow to a same size or smaller. So this, you can also go to both of them. This one, you can go to both of them as well, right? Like something like this would work. This one would work like this or like this. And finally, this one is on both. But if you have a cell like this, then this can go to the Atlantic, but it can't. Essentially, there's like this diagonal that it can't cross, right? Because it can't. You have to only go down or the same. And so in order to do this problem, we're actually going to do a kind of a different strategy. Instead of figuring out cell to cell whether it can go to both oceans, where that is probably like an approach, right? Like you can probably just like try to see, like do some kind of like maybe DFS or BFS from every cell. But there's like a better way of doing it, right? So you could go cell by cell, do some kind of DFS or BFS, and then if you ever get out of bounds, then you can get into an ocean, and if you get into both, and that cell is valid. Like that might work, but you're going to be doing like a decent amount of repeated work in that way. So we're going to be doing another strategy essentially. And instead of focusing on like the cell, what we are actually going to do is we're going to have two stacks. And yeah, so technically with a BFS, you can use a queue, but in this case, so normally the reason for a BFS why you use a queue is because the order that your elements get in matters. And so you're trying to find like a shortest path or something. But here you're just trying to figure out like, is a path possible? So you don't need a queue. And in JavaScript, a queue is slower than a stack, right? Popping from a queue is O of n. So we'll just use a normal stack. And essentially the plan will be like this. So we're going to have two stacks, right? We're going to have a stack of every cell that the Pacific Ocean borders, which will be these cells here. We're just going to initialize it to like every cell here and every cell of the Atlantic Ocean borders. And essentially what we're going to do is we're going to start with like the Pacific Ocean. So we're going to have a stack of all these things. And we're basically going to BFS and see if we can get from like if you can get from what cells can you get from here to, and any cell that you can get from here to would flow into the Pacific Ocean. So because they're saying that, you know, when you have a cell, you can flow to the same length or lower, right? So if this is 5, you can flow to anything lower or the same length. We're kind of do the opposite, where we're going to kind of go up, right? So we're going to go up the mountain. So the only way we can traverse from these starting cells is the same number or higher now. So for example, let's say we have these. Let's just kind of show what this would look like. So essentially what's going to happen here is for a BFS, we're going to say like, can we get to 2 from one of these? Yes, we can get to 2 from this one, right? So we can get to 2. Can we get to 3? Yes. Can we get to 4? Yes. Can we get to 4? Yes. Can we get to 5? Yes. Can we get to 4? Yes. Can we get to 7? Yes. But we can't go to any of these, right? Because we can't go down. We have to go up or we have to basically go up or or equal. So these are the cells we can get to from the Pacific Ocean. And similarly for the Atlantic, we're going to do kind of the same thing. We're going to take these cells and we're going to try to also see if we can go up. So we can go here, 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 here. We can go up, remember, so we can go up this way. This is the same. We can go up this way. We can go up this way. And I believe that is every cell, right? So you could see like all these ones that were the dark colored ones, we were able to get to from both if we follow the plan of we can go to a cell with greater or equal number, right? We're essentially doing the reverse. So before we were going down or equal, now we're doing the reverse and we're starting at the oceans. And basically what's going to happen here in this BFS is we're just going to check, we're going to have a set of visited cells for the Atlantic and Pacific Ocean, right? To make sure we don't like visit the same cells again. So essentially we're going to do a BFS from both of them. And we're just going to check, we're going to have two sets. So we're going to have like a Pacific set and an Atlantic set. So Pacific we'll have a set here, and Atlantic set, and basically what they represent is all the cells you could get to from either ocean. And then you could just traverse one of the sets and make sure that, and you just get every element that's in the other one, right? So Pacific set will have like all these cells, and you just check like if it's in Atlantic as well, then you add it to the result. And that kind of makes sense, right? So essentially you are, instead of going down, you start at the ocean and you go to the cells. And that's kind of it for this problem, but it's a hefty amount of code, so I wanted to go into the code and kind of like try to describe everything. And also this is one that is a really good practice for like once you get a solution, try to clean it up a little bit, especially in TypeScript, it gets pretty long pretty fast. So we're gonna look at it and try to like see what like a clean solution looks like. Okay, so let's go into the code here. So what we need is we need rows and columns, right? So we're going to have const rows equals heights. And I think this has to be like at least a 1x1 matrix. We don't have to check if we're like don't have anything. And we're also going to have columns equals heights 0. So we're going to have the rows and columns. Now we want to have the directions that we can go into. So this is good for DFS and BFS. So we'll have const directions equals, so you can go, and this is like all the normal directions, right? So it's all combinations of like going up one or down one or right one or all these things. So -1, 0, 0, -1. I think that's all of them. Oh, I probably missed a column somewhere or something. Let's see. Oh. Okay. And now what we want to have is we want to have like the actual stacks for all of the cells that connect to the Pacific and all the cells that connect to the Atlantic Ocean. So we'll have const Pacific equals, and it's basically going to be type number array, right? So it'll be a nested array, 2D array, where every single internal element will be of type number, and we'll make it this. We have another one for Atlantic. And yeah, these are basically our stacks that we're going to use for the breadth first search. Okay, now what we want to do is we want to actually initialize them to all the cells that connect to the oceans. So what we can do is we can start with a row. So basically our plan is we're going to go row by row, right? So we're going to go row by row, and the Pacific Ocean will have all of these cells, and the Atlantic Ocean will have all of these cells. So this is column 0, and this is the length of the grid -1. So that's essentially what we're going to do there. And then we're going to do the same thing column by column, where the Pacific Ocean will be row 0, and then the Atlantic Ocean will be the last row. So we're going to do that. And let's do that. So we'll say for let I equals 0, I is less than rows, I plus, we want to add to Pacific everything at column 0 and the row. So we'll add I0 here. We want to push. And we do the same thing with Atlantic, but instead of adding at column 0, we add at the last column. So Atlantic dot push I. And then the last column is just the length of the number of columns -1. So it's going to be columns -1 here. So there we go. And we do the same exact thing for the column. So we'll say for let I equals 0, I is less than columns I plus plus Pacific dot push. This time we're going to push everything at row 0 and the column. So we'll do I and Atlantic push. We're going to push everything at the last row, which is this row over here, and I as well. Okay, so now that those are made, now we're just going to make a generic BFS that's going to return to us a set. So it's going to return to us a set of all the visited locations given one of these stacks, right? So we're going to pass in one of these stacks, and then we're essentially going to try to BFS to see like everywhere we can visit from there. So we're going to have a function. I guess we can have a const. Oh, let's make a function. So make a function BFS, and it will take a stack, and it will be of this type, right? So number array, and we are going to return a set of a string. So essentially, because it's going to be a row column, if you're going to use a set, essentially what we're going to do is we're just going to make a key. So our key is just going to look like row column with a string. So that's like a really common way to make an easy key. And we'll just say const reachable here. This is going to be the set we're going to be returning. Equals set string new set. And we're gonna like go through our stack as long as there are elements in here, right? Kind of like a BFS. Except instead of a queue, we can choose a stack. So as long as the stack has elements, so I'll stack.length. And so what we need to do is we need to actually pop from the stack, right? And so remember, the stack is going to have a 2D array of every single element will be number, which will be the row column. So we'll say constant. We can destructure here, rows column equals stack.pop. And you do have to specify a type. I think in LeetCode you don't, but if you actually wrote this in a text editor, you would have to specify type here because it doesn't know like what type you're popping. So you can just specify it's this type. I know it's this type. Okay. And now we're going to add this to our set. So reachable.add. And we're going to make a key here. So we're going to say the easiest key we can, right? We'll just say like row, comma, call. We just need some kind of way to like make a key out of here because you can't do like row plus column or something here, right? You might have like duplicate keys that way. So this will ensure if you just put a comma between or like a slash or whatever works, all those are fine. And then what we need to do is we need to try to go to every single direction from here, right? So we'll say const xy of directions, destructure the direction because remember direction is also a 2D array here. So we're going to say const new row equals 0 plus x and const new column equals column plus y, right? So we find the new row and the new column. And now we have to check a lot of conditions to make sure this is valid. So there's going to be a lot of things here. So first we have to check for inbounds, right? So we have to say like if new row is, this actually has to be, oh yeah, so what we're going to do is we are going to, we're going to have a bunch of conditions for failure. And then if any one of those is a failure, then we'll fail. Otherwise, we'll do stuff. So these are all the conditions for failure. So what we need to do first is like if we're out of bounds, so like if new row is less than 0 or new row is greater than or equal to rows, that's a failure condition. Then same thing for the column. New column is greater equal to columns. That's a failure condition, right? We're out of bounds. Then we also need to check like, so remember the new row has to be greater than or equal to the old one, right? We're traversing up. We're kind of doing the reverse of the rain. So if it's less than, then it's no good, right? So it's heights, new row, new column is less than heights of the old one, then we can't traverse this way. So that's also a failure condition. And finally, have we visited here before, right? That's also no good. So if reachable.has, and then we're going to make that same key, we can even copy this key. Just do new row, new column this time. So new row. So if we already visited it, we don't need to go there either. Not sure what issue we have here. I guess we'll figure it out. It might be just because we don't have like anything after the if. That might be the case, but we'll figure it out anyway. Oh, actually, I think I know what it is. It's actually because this is this needs to be like outside. So and anyway, so this is continue, right? We're just done. Let me just make sure that this is lined up. So this is a for loop. This is the while loop. I think we're probably missing like one here. So this needs to be like here to close the BFS. Let's just make sure all these parentheses are correct. Yeah, that's fine. This needs to be over here. Maybe we have an extra one. Let's see. Okay, I think we're good now, hopefully. Okay, yeah, this one's kind of hefty in code. Okay, so essentially, if any of these things happens, let's continue. Otherwise, we're going to add this thing to our stack. So we're going to push the new row and the new column, and the new column. And then we also are going to add it to our visited set, right? We don't need to push it into the stack again, right? There's no point. So we will just do that. And let's see here. Yeah, reachable add column here. This needs to be like this. So essentially, yeah, we can just do it again. Okay. We are adding twice, but that's fine. Like this just makes sure our stack is as small as possible and it's a set, so it doesn't really matter if we add twice. It's totally fine. Okay. Yeah. Oh, I think I might have actually been missing one. Yeah, for some reason. Okay, so I think if this is here, actually, let's see. So this is the if statement. This should be the while. Oh, this is the for. Let's see. Okay, this is the for. Then we need one for the while loop, and now I think we're good. Okay. And so after the while loop, finally we return the set. So essentially, just to go over it one more time, essentially what happens is this BFS function will return to us a set of everything that we visited given some stack. And so we need to do this twice, right, for both of the stacks that we have. So we'll say like const Pacific reachable equals BFS of the Pacific stack, and same for Atlantic. And so this is like pretty good practice to do, like making a helper function that you can just call twice instead of like writing out this entire chunk of code for both the oceans, because yeah, otherwise like this is already pretty long. This is like 50 lines of code. If you didn't make any kind of like optimizations or helper functions, it would be like 90 lines of code or whatever. This get kind of long, and it's good practice. Okay, so we're gonna have our result now, and basically what we want to do for our result is we actually want to take everything in the Pacific reachable, check if it's in the Atlantic reachable, and then if it is, then we want to put it in our result. So what we can actually do is we can do something kind of cool in TypeScript. So you can just do this, Pacific reachable. So essentially we're just saying like, let's just take our set, turn it into a list, and then we can filter it. So we'll filter it by an element P, and what we want to check is that if the Atlantic reachable also has it. So we'll say Atlantic reachable dot has P as well. And if that's the case, then remember this is so the format we are storing our stuff in is row column like this, and it's a string. So what we need to do is we need to separate it out by the comma, and then we can just turn it into a number array. So the way you can do that is you can just do dot map, and then you'll have like a coordinates, let's say, and basically you can do coordinates dot split on the comma. And then what will happen here is, so we have our string, right? Like let's say we have like 510. This will split it into 510, but these are both strings. And now what you can do also that's kind of nice is if you have an array of some type, and you want to turn it into integers, if you want to have strings that you want to turn into integers, or integers you want to turn to strings, or any of that kind of stuff, essentially what you can do here is you can actually map that as well, right? So basically what's going to happen here is we're going to have a coordinate, we're going to split it, and then we are also going to, after we split it, it's going to be a string array, and then we'll just map that into a number array. And you can literally just pass it number, and that's a function. So what will happen here is we'll have a coordinate, right? So let's just kind of walk through that. We'll have a coordinate like this. Let's say we have 510. it will get split into an array. So we'll have like this. And then it will get changed into numbers. So it'll get changed like this. So we'll take this key and get an array. And then finally, we can add that to the result. And yeah, so now we just need to return it and pray that it works. Alternatively, if you don't like this kind of format, you could literally just do like a for loop, right? So you could say like for key in this thing. If it's also in this thing, then let's split it. Let's take the values or, whatever, and put it into the result. So you don't have to do this kind of thing. I don't know. Let's see. I think we have a working solution. Nice. Okay, cool. So let's go through the time and space. This is one of the longer ones that we've written. So not Python. So it's mostly going to come down to like this BFS part, right? So like this is all whatever. This is also, like O of one of these dimensions. So it basically comes down to like how long is our BFS. So essentially what happens is our BFS will get some stack, and then we are just traversing and getting every other location, but we have this visited set. So we're ensuring we're not like adding things to the stack multiple times, right? We're ensuring that at most you can only add an element one time and you can only delete it one time. And so that's going to be O of m by n because we do have this visited set. And then afterwards, when we check for everything in the visited set, this can only have m by n items max. This can only have m by n items max. So this filter map and all this stuff is O of 1 basically, because to check if something is in a set is O of 1, to split it is O of 1 because our coordinate is only going to have 2 elements, and to map it is also O of 1 because it's like 2 numbers. And for the space, all of these things will have maximum O of m by n numbers, right? The Pacific reachable, the Atlantic reachable, these stacks will have maximum m by n numbers. So that's our time and space for this. And yeah, I think this is really a cool problem if you want to practice your BFS or DFS. You can also rewrite this if you want to practice DFS. And the idea for DFS is you would just loop through every element that starts at Pacific, add it into Pacific, DFS down as far as you can go, add that all into the Atlantic data set, right? So take everything that starts at Pacific, everything you can visit, or actually, I take that back. So everything that starts at Pacific, you DFS through, you add it into the Pacific visited set, and then you take everything that's Atlantic, that borders Atlantic, DFS as far as you can go, add that all into the Atlantic data set, and then do the same kind of thing at the end instead of a BFS. And that would be the same time complexity. So if you want to practice DFS in a matrix, this is also a great problem. And I think I did have previous solutions where I did this into DFS. I'll probably link that one as well, where I literally did this exact same problem in Python in a DFS. And yeah, really good problem to practice. I think it's probably a popular interview problem. Let's take a look. Not as popular as it used to be, but definitely if I was interviewing, this would be a good one to ask for me. Okay, so yeah, that's going to be all for this one, though, and hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.